Okay, so first I need to find that queue. So I'm just going to cut and paste. I want to create a new interface. To 11 E finish. Save. So now I want to create my class. And so it implements the interface. Finish. And they're so nice to me, they give me all the methods. So my E array data. What did I forget? It's private. My private int front, private int rear, private int size, and then might as well just implement this. Return size. And then we wanted to do add. So since we're adding to the array, we always need to check to see if the array is full. How do we do that? If size is equal to data.length. I get my red squiggly because I haven't implemented it. So I'll create the method, but I don't have to do anything.
There also is an empty method.
Is empty. Not, that's a stack. Stack actually has an empty method.
No, I was thinking of the next method anyway. It was relevant to this.
But there is no is empty or empty method officially defined in your queue. You have a size. It's empty when size is 0. Right? Because the idea is you know how many items are in the queue. In a stack, you don't, the concept of how many items are in a stack is not defined. There is no, you can just have access to the top. You know it's empty or you know it's not empty. Now, that doesn't stop you from implementing an empty method on a queue. It's just not part of the abstract data types interface. So, we add items to where in a queue? The rear. And since our rear points to the next open spot, we just have to say data.rear equals E. Size plus plus. And now we need to increment rear. So plus 1. And then we have to make it circular. If I could make it percent. Mod the data.length. Or capacity if you're keeping track of the capacity. The one thing I would say, and that's not a huge critique of the book, is if you keep track of the capacity, there is a chance that you didn't update the capacity correctly when you reallocated. There is not a chance of having data.length be wrong. So keeping track of the capacity is fine. It just leads to a potential error, or can lead to a potential error. Using the array's length is not going to give you an error. See, I can't hear you. Yes, it should return true. I'm not done with that. Because this will always work. We do want to return true. And then, what did I ask for? Remove? Okay, so the remove method may throw an exception, right? This is the one that throws the exception. The pull method returns null. So, how do we know we're empty? Size is equal to 0. Does this say anything about where front and rear are? We don't care. Oops. Throw new, no such element exception. And I need to import that exception. Okay, so now we know that we're okay, and now we want to find the item at what end of the queue? The front. So right, we want to remember it. So now we can size minus minus, because we're removing it. We need to update front. Which way do we go? Plus 1. I'm being paranoid. I don't know if you need the mod length, data.length. Or capacity if you're keeping track of the capacity. And then we need to return period. Control period. Oh, return. Okay, have completion. Now, if I do the pull method, what's the difference between this method and remove?
On the quiz, you said that you may throw illegal state exception.
Right, whatever exception is it.
Okay, I wasn't sure, so then that's what I threw instead. Like,
No, as long as you throw an exception,
Okay.
because the quiz says something, that's, again, the quiz's interface question was that the code did not show the interface. So, I'm not going to take myself.
Okay, great, yeah, because I was confused by that. Just threw what you said.
Well, on the quiz, I looked at the Java doc for the queue, the Java queue, and it doesn't throw an illegal state exception. The book one does, I believe. One is no such element exception is one example. One says illegal state exception. Again, in either case, you're throwing an exception because you can't get that item.
Basically the same one.
So, for the pull method, which doesn't throw the exception, there's a couple of ways. Here's a silly way.
Just catch it. Exactly.
You say silly, but that's what I was going to do.
Yeah.
The silly part is this is actually more expensive when it comes to performance. Because you have to generate the exception, you got to throw the exception has to be caught. That's all processing that the JVM must do, where you could have just checked the size. Right? An if statement is a lot quicker than creating an exception, throwing the exception, catching the exception, and then processing.
So, like, it'd be better to implement pull and then you remove call pull and then throw exception.
That could be, again, you got to be very careful on the semantics of being able to add null to your queue.
Because then if you return null, that's
How do you know it's empty? So it's you really should be checking the size of the queue. That's how you know that you're in this place where you want to return null. Not, or you, again, actually we could do it faster. Let's make it even faster. God. So I can either return the result of remove or catch the exception and return null. This is less typing, much more confusing to look at, in my opinion. But it is legitimate. I would not recommend you use this, but I would actually do the if size null else dot dot dot. That's, I would prefer this solution, but again, it's programming. You could do it because both of these, what's the big O of both of these solutions? It's big O of 1. There are no loops. So it doesn't matter how big the queue is. It's always going to be big O of 1. One's got a larger coefficient because we have to create the exception, throw the exception, catch the exception, versus do an if statement. So the preferred, more efficient solution is check the size. But it's programming. That's the beauty of programming. Can I?
I mean, the call method shouldn't be exceptions.
The poll method should not throw the exception. One of them throws the exception, the other one doesn't.
The remove throws the exception.
Right, so the poll does not. It returns null if the queue's empty.
If you're catching the exception inside,
You can.
is it valid?
Yes, I can catch any exception I want inside. And then go back. So this is completely correct code. The remove exception will throw the remove method will throw a no such element or illegal state or whatever exception if the queue is empty.
You just prefer not doing this because we wouldn't have to call it a function.
Well, I prefer not doing this because when you throw and catch exceptions, that's expensive operation. The JVM's got to do a lot of work. Create a new instance of the exception. They got to figure out where in the stack trace you are, because each exception has a stack trace of where it was generated. It's got to build all that stuff. You then throw the exception, and then you immediately catch it, and you ignore all that stuff. So you throw it all away. It's completely legitimate. It works. It's still big O of 1. It's just more expensive when you actually run it than checking to see the size is 0 and returning null. So does that, I can catch the exception, and by catching the exception, it does not get populated, or does not get out of this method. So this method doesn't throw any exceptions.
If we're testing our methods, right, it'd be better to use the element or the.
Well, if you're testing them, you need to test all of them.
Well, yeah, I know, but I mean like testing to see if something